So I wanted to do another example applying the squeeze theorem to a problem. In this case, we're going to find the limit as x goes to 0 of x times cosine of 1 over x. Now, here's the thing. One of the things you probably noticed is that we cannot plug in 0 and actually find out the answer. Again, x is in the denominator, so we would end up trying to divide by 0. Can't divide by 0. So, the other thing you probably noticed is that with the squeeze theorem, we tend to do a lot of things with sines and cosines. The reason that is, sines and cosines oscillate. They go back and forth, along with all of the other trigonometric functions. And in this case, when you're dividing by x, the frequency of their oscillation, how quickly they go back and forth, changes. And so it's hard to pin down. Is it going one way? Is it going the other way? And so the squeeze theorem helps us pin down exactly where it's going to be at that value. And so here's what we're going to do. We're going to go ahead and try to approach this the normal way, but I realize that there is a common mistake that happens with this problem, and I wanted to just kind of highlight that as I go. So, in the last video, we talked about saying that sine and cosine were between -1 and +1, which is it's a true statement. In this case, though, that's the mistake. That's not really where I should start on this one, and I'll come back to the reason why in just a second. And so here's the thing. If I wanted to make this middle part, this middle function, look like my original function, what I want to actually find, I need to multiply by this x. And so I'm just going to go ahead and multiply by x. So we're going to have a negative x is less than or equal to x times cosine of 1 over x is less than or equal to x. Now let me go ahead and show you what this picture looks like just to get my point across. In this situation, negative x is this straight line that starts in the top corner and ends in the bottom corner, in the opposite corner. So, top left, bottom right. The other function, y equals x, goes the opposite way. It starts in the bottom left and goes in the top right. But so in order for the squeeze theorem to actually apply, what has to happen is one of the functions has to be on top around 0, in this case, and the other one has to be on the bottom. But in this case, if you notice, on the left side, the pink one's on top and the purple one's on bottom. Negative x over positive x. But on the right side, the purple one's on top and the pink one's on bottom. They switched. So here's the thing. In this situation, I don't have a function that's on top consistently and another function that's on the bottom consistently. So that's where the mistake lies. Again, common misconception is to automatically do this. In this case, that's not the best option. The best option here, and I'm just going to show you real quickly, is instead of saying it's between -1 and +1, I'm going to rewrite it ever so slightly to make it just that much better. So here's what I'm going to do. I'm going to add absolute values to this. Now, at this point, I don't have to say it's greater than -1. I don't have to worry about that anymore. That's okay. Now, here's the thing. I'm going to also add it to the end just so it's consistent. So this is the absolute value of 1. Now, here's my thing. When I do this, these absolute values still make it true, because think about it. Any negative number is still going to come out positive. So it's still a true statement. This works. Is that even if I have a negative number coming out as my cosine answer, the absolute value is going to make it positive. It's still going to always be less than the absolute value of 1. So here's what we're going to do next. Now I'm going to put the cosine and the x together. I'm going to put them both inside the absolute values. So here's what I've got. X times cosine of 1 over x inside the absolute values is less than the absolute value of x. Okay? Again, let me repeat. I just stuck the cosine and the x in here in the absolute values together, so I had to do it over here. I had to stick the x in the absolute values. So, now that I've taken care of that, what I can do is try to remove the absolute values around this, because I want it to be this function up here. It's just a little trick that I had to add in the absolute values. And so what I'm going to do is, instead of having the absolute values here, I'm going to switch the signs. One of them's going to be positive, one of them's going to be negative. So I'm going to have the negative absolute value of x is less than or equal to x times the cosine of 1 over x is less than or equal to the positive absolute value of x. So notice it's slightly different than what I had before. In the last situation, I just had a negative x, plain old negative x, and a plain old positive x. In this case, I've added an absolute value. Again, the reason that's going to help me out here is because if I look at my picture, again, I'm going to try to use the pink or the red and the purple. The purple one, the positive one, is going to look like that, where it's y equals the positive absolute value of x. And in the other side, y equals the negative absolute value of x. Now one of them is consistently on top and consistently on bottom, and it's still a true statement. It still works for me. So in this case, I can now start plugging stuff in and seeing what the limits are. In this case, I'm going to take the limit as x approaches 0 of the negative absolute value of x. If I just plug in 0, guess what happens? We're taking the absolute value of 0. It's 0. Make it negative. Still 0. On the other side, we're going to take the limit as x approaches 0 for the positive absolute value of x. Again, plug it in. Absolute value of 0 is 0. So my answer is 0. That means that this function up here at the top, its limit is 0. And that's it. But make sure you pay attention. Be very, very careful. My functions have to be on top consistently or on bottom consistently. It always helps to make a graph or to look at it. Okay? Have a great day. Bye.